Controlling multiple LED assembly components require NodeMCU, IC7805, 4 LEDs, one 220 ohm resistor, a 9 volt battery snapper and a breadboard. First of all, place the LEDs on the breadboard. Now take the male to female jumper wire and connect the positive of the first LED to the D1 pin of the NodeMCU, the positive of the second LED to the D2 pin of the NodeMCU, the positive of the third LED to D3 pin of the NodeMCU, and the positive of the fourth LED to the D4 pin. Now connect the negative, that is the cathode of the LED, to the negative line of the breadboard. Connect all of them so that they get shorted. Now place the voltage regulator on the breadboard. Take a 220 ohm resistor. Connect its one terminal to the negative line where all the cathode of the LEDs are connected, and the other terminal to the ground pin of the voltage regulator. Now take the battery stepper, connect its negative to the ground pin of the voltage regulator and the positive to the input pin of the voltage regulator. Then take another male to female jumper wire, connect its positive, connect it to the Vout pin of the voltage regulator and to the Vin pin of the NodeMCU. Similarly, take another wire, connect it to the ground pin of the voltage regulator and the ground pin of the NodeMCU. There are 4 ground pins on the NodeMCU. You can connect it to anyone. So we can connect the NodeMCU to the battery for the power, or we can directly use the USB port and connect it to the NodeMCU for powering. To connect the NodeMCU to the laptop power, we don't need the voltage regulator or the battery stepper. In that case, you can simply remove this part and only connect the ground pin of the LED cathode to the ground pin of the NodeMCU, and you don't have to connect the Vin pin. Thank you. Configuring the Blynk cloud for multiple LED controlling. First of all, open the Google and open the Blynk app. Here, first we will create a new template. For that, first of all, click on New Template. Then give the name as, I am giving control multiple LED. You can give anything. Then select the hardware as ESP8266, connection type as Wi-Fi, and click on Done. Your template is created. Now this is the template ID and the template name. We will use this later for the coding part. Now we will create the data stream. So click on data stream, click on new data stream and select it as digital. So first we will name it as LED1 for the first LED. Then for LED1 is connected to the D1 pin and the GPIO pin for D1 is 5. So here we will select the pin as 5 and the pin mode as output and click on create. your first data stream for the LED 1 is created. Now we will create the data stream for the second LED. So click on new data stream, click on digital, write the name as LED 2, and the second LED is connected to the D2 pin. The data stream, the GPIO pin for D2 is 4. So select 4 here and then click on create. So the data stream for the second LED is created. Now again click on new data stream, click digital, and now we will create a data stream for LED 3, and the pin, since LED 3 is connected to D3, the GPIO pin for D3 is 0, so select 0 and then click create. The data stream for the third LED is also created. Now for the last LED, again click on new data stream and digital, write the name as LED 4 and give the pin number as 2. Since the GPIO pin is 2 for D4 pin, so click on create. So we have created the data stream for all the LEDs. Now click save. Before that, click on web dashboard. So here we are going to add widget. So from widget box, click on switch, drag the switch. You can drag its size and make it small or big. Click on settings, then here give the name as L1, LED 1, whatever you want, and choose the data stream as LED 1 and then click on save. Similarly do it for the other 3 LEDs. For L2 we are going to select LED 2 and then click on save. Again bring the switch, place it here, go to the setting, write the name as L3, choose the data stream as LED 3, click on save, get another switch, so click on setting, name it as L4 and select LED 4, save. So all the 4 switches for the 4 LEDs are created. Now click on save. So the template is created. Now we need to add the device. Click on adding new device. So let me just delete one. From template, select the template we have created, that is control multiple LED, and click on create. Your device is created and this is the token of the device which we will require in our code so that our NodeMCU gets connected to the Blynk. So the device is created. If I click on device info, it is showing the status offline since the NodeMCU is not connected right now. As soon as we will upload the code and connect it, this status will be shown as online. So this is all about the Blynk cloud configuration. Mobile configuration for controlling multiple LED. First of all, open the Blynk app. Then, as you can see, there are 2 templates. This is the control multiple LED template. Click on this template. Then click on the setting option and then click on the plus option. Select button. Since there are 4 LEDs, we are going to select 4 buttons. So click on the first button selected. Choose the data stream as LED 1. I will change the color of the button. So here, changing the color to red. Now we will go back. See, it is showing the data stream in the button. Similarly, I will add 3 more buttons. Choosing the data stream of the second button as LED 2 and changing its color. Coding for controlling multiple LED. First of all, open the Arduino IDE software. Here first we have defined the Blynk library by typing define Blynk print serial. Then we have included the ESP8266 Wi-Fi.h library, and then we have included the Blynk simple ESP826.h to connect the Blynk and the NodeMCU. Then we have given the device token, this one, which we have got from the Blynk cloud. So here in the Blynk cloud, this is the token. So you just have to copy this one and paste it here. Store it in the variable auth here, the token. Then the SSID is our Wi-Fi network name, and the password is the Wi-Fi password, which we have stored in the password variable. Now in the void setup, we have declared all the LEDs as output. We have used the pin mode function to declare the LED as output, since we know the first LED is connected to the D1 pin. D1 is equal to GPIO 5 pin, so here we have written 5 as output. Similarly, for D2 the GPIO is 4, and so we have given 4 as here output. D3 GPIO is 0, so here it is written as 0, and for D4 it is GPIO 2, so we have given 2 here. Then we have given blink.begin, and here auth is the token auth, SSID is the Wi-Fi name, pass is the password, Blynk cloud, and 80 is the your channel. So this is given to initialize the Blynk library, and then in the void loop we have given the code as blink.run to run the Blynk library. So it's done. Now from tools we have to select the board as NodeMCU, this one, NodeMCU 1.0 ESP12E module, and the required port, and click on upload. Your code will be uploaded to the NodeMCU. Output of controlling multiple LED using the Blynk phone app. So open the Blynk app, click on the template control multiple LED. As you can see, we have added 4 buttons. Now if I press on the first button, my first LED is glowing. Again and it's showing on. Now if I press again, it shows off and my LED has turned off. Similarly, the second LED on, off, third LED on, off, fourth LED on, off. Thank you. Output of controlling multiple LED using Blynk Cloud. So first of all, open the Blynk website, click on login. So it's showing the 2 devices we have created. Click on the control multiple LED device. As you can see in the dashboard, there are 4 switches for the 4 LED. So when I click on the first switch, my first LED is glowing. And if I turn it off, it turns off. Similarly, the second LED. And now it has turned off. Now click on the third, and have turned off. And lastly, the fourth LED, it's turned on now, and when I turned it off, it turns off. Thank you.